Okay, everybody, let's get started. Um, First of all, I have assigned you the homework set 3 and I sent out an email. Have you all received my email about homework 3?
Yes.
Okay. Yeah. Yeah. So actually, I am late on day to let you know about that. I think on Friday I told that by Friday I will be uploading, but I could not do. I was engaged with lots of activities. So finally, I did it on Saturday. That's why I have given you the deadline again, October 3rd, Saturday, midnight almost. Um, I think there were 8 problems. Uh, Let me open that on for a moment. Can you see my screen?
Yes.
Yes.
That homework set 3. As I mentioned in the email, I mean, as of now, as of your current knowledge, you will be able to solve number 2, 3, number 4, number 6, and number 7. But number 8, a little bit different. As I said, the realize the following function that I will be discussing today. And also the transfer function calculation, I mean, question 5 and question 1. Although you might have already covered in signal systems class or other class, but from my side, I will be covering today the transfer function. And then I believe you all will be able to solve all the problems. And then please submit by October 3rd. So does anybody have any question on the homework?
Not yet.
Yeah, okay. Right. So after today's class, you start working, and then if you have any question, confusion, then please let me know. Okay. Let's stop sharing this on. Okay. Now can you see the transfer function?
Yes.
Okay, great. Um, as you see, because we are looking the Laplace, one important thing of that Laplace is the transfer function. So transfer function is the ratio of the output response to the input excitation, assuming that all initial conditions to be 0. So this means that for every circuit, there is an input. So which is called that input excitation. And then the output response, it could be voltage for any specific branch or current flowing through any specific location, specific branch. That is the meaning of output response. So this means output could be voltage, it could be current, and then whatever the input is. So that is the meaning that transfer function is the output over the input that you have to do. And typically you see the equations, typically transfer function is denoted by symbol HS, capital letter HS. And Y means that is the output response, Y. And then X means that is the input. I mean, these are the traditional symbols that is used for the transfer function calculation. So, and then as you can see, I have written the transfer function Hs, it could be voltage gain. So when it is voltage gain or voltage transfer function, it could be the ratio of output voltage to the input voltage for any specific branch. Similarly, it could be current to current ratio. So in that case, it is called the current gain. Also, it is called the impedance or admittance, transfer impedance or transfer admittance. For example, voltage over current. So you know that because voltage over current is impedance in terms of AC circuit, and current over voltage, it is called the admittance. So accordingly, the name goes transfer impedance HS V over I. H is transfer admittance I over V. So it depends on the problem, it depends on the situation when to calculate voltage gain or current gain or transfer impedance or transfer admittance. So soon I will show you in terms of a numerical example and then you all will be fine. I will show you a few problems. So therefore, you see from this on, from the first equation, Hs equal to Ys over Xs, so you can write that output response Os equals to Hs multiplied by Xs. Now, there is one special case when the input excitation is a unit impulse function. Unit impulse function means that del t. Here I have written xt equal to del t. And so you know, I think in the last class I was showing you the Laplace of del t is 1, because unit impulse function means it has the value only at the 0 point. After 0 and before 0, it is always 0. So therefore, del t means it is unit impulse function. It has the value 1 only at the 0 point. That's why its Laplace transformation xs equals to 1. So this means, look this equation, y is hs multiplied by xs. In case of a unit impulse function, because xs is 1, so we are getting ys equal to hs. I have shown here. So this means you can say in time domain yt equal to ht. Yt is its time domain function and ht is hs time domain function. So this means ht is Laplace inverse hs. So, and then in that case, you can call ht is the unit impulse response of the network because of that unit impulse excitation. So now I will show you a numerical example about this one, where there is a unit impulse function. So I think probably in the signals and system course, you might have already looked this transfer function definition. So now let's have a look in terms of the circuit standpoint and see few problems. Then you all will be fine. Everybody see this circuit. Look the problem. For the following circuit, determine the transfer function. H is V naught is over I naught is. So therefore, everybody see the circuit. There is a voltage source which is Vs, and this is the I naught current flowing through 1 ohm. There are two parallel branches. In this branch, it's S 4 ohm. The circuit is already expressed in terms of Laplace, so you don't need to do anything. It is not time domain, it is directly in Laplace domain. And then in this branch, you see, on over 2s, and then 2 ohm. So, and even the currents are given. Current flowing through this branch is I1, through this branch is I2. So see what you have to find out, V naught over I naught. So this means that you have to find out this current, I naught. Also, you have to find out the voltage here, V naught. And once you are able to find out V naught and I naught, and then just calculate the Hs. That's all what you have to do. So therefore, just by looking the circuit, everybody say, because you have to find out the V naught here, this means if you know what is the current, what current I2 that is flowing through the 2 ohm, and then if you multiply I2 by 2, that is your V naught, right? And then you can find out I naught. I naught is the total current. So therefore, you have to make the parallel combination of these two and then series of this resistance. And then that will be your total impedance. And then you divide by the voltage. This is Vs. So Vs over Z total. That will be your I naught. And once you know the I naught, and then you apply the current divider rule at this point, because this current is coming, it is going. After coming at this point, it is being divided into two parts. One part is I1, the other part is I2. So you have to find out I2. So therefore, once you can calculate the I naught, total current, then you can easily find out I2 and then multiply by 2. That will be your V naught. Everybody, could you follow me?
Yes.
Yeah. So therefore, now let's have a look, see the calculation here. First, I have written that thing, that V0 is I2 multiplied by 2. So this means that I am simply writing this on first. V0 is 2 multiplied by I2. That's why I wrote in that way. And then you can see I am finding the I2. So what I am doing, I2 means this total current. I am applying the current divider rule. So I2 is, you see, this current, then multiplied by this one, S plus 4, and then divide by this plus this plus this plus this. Current divider rule. So everybody see this line? I2 is I0 as total current, and S plus 4 is this one, this combination. Because I am finding current here, so I have to multiply it by this impedance and then divide by sum of all those 4. Yeah, look this one. And then from there, you see, actually what you have to do, actually you don't need to find out the I0 because it is given in terms of the I0. So automatically it is coming in the expression. So although I was explaining, you have to find out total impedance, but you don't need it. It is directly coming in the form of I0. So after that, you see, this is my I2 and my V0 is this one. So V0 is 2 multiplied by I2, this whole thing that I have written. So after that, you see, my question is to find out V0 over I0. So therefore, everybody say I0 is here, V0 is here. So that's my transfer function. HS is V0 and then over I0 here. So therefore, look, in the numerator, I have 2 into S plus 4, and in the denominator, I have S plus that 4 plus 2, 6 on over 2S. And then just simplify. So numerator is as it is, in the denominator this one, 2S will go in the numerator, so it will be 4S plus 1, and then just this one, 2S square plus 12S plus 1. That's the answer. So you are done. Could you follow me? Do you have any question?
Could
Can you
you,
review,
yeah, go
Sorry.
ahead.
could you review how you got V naught?
Okay. So therefore, first of all, look the main circuit. So V0 means you have to find out voltage across 2 ohm, right? So if you know the current is I2, it is designated. It is defined by the symbol I2.
Oh, I see. I see. We just replace I2 for V naught. I get it. Sorry.
Yeah. So this means V0 is 2 multiplied by I2. So that is the very first line you see, top. I have written that on.
Yeah. Okay. I get it. Thank you.
Okay, most welcome. So I think anybody was telling anything. So is everybody fine? You see, this ion is the current divider rule. I2 just current divider rule. So therefore, when you have 2 parallel branch, how to calculate the current? So therefore, for example, if you want to find out current this one, I mean the ion through this branch, then total current multiplied by this combination and divide by the sum of this. So in this problem, I am finding the current I2. So therefore, current divider rule is that total current I0 multiplied by this impedance S plus 4 and divide by S plus 4 plus 2 plus 1 over 2S. This is the current divider rule. And then after that, this is the V0 that already I have written. Just to substitute. And then look the problem. Problem is V0 over I0. So then just make a relative. Already you can see it is V0 here and I0 here. So, and then rest of the thing is the just calculation and simplification. So everybody is fine.
So would it be a wrong approach if you treated this like a DC circuit in the time domain and shorted out the capacitors and opened up the inductors and then found the current and the voltage that way?
So you don't need to convert. This is the, already the in Laplace domain. You see, this is already in Laplace domain.
Right.
Yeah. So you see, this is S 1/2S. So therefore, you don't need to go back to the time domain.
Well, is that virtually the same thing, but just by taking out the calculus?
Yes, exactly.
Okay.
So therefore, I mean, always you will be noticing that all the transfer function problem that we will be dealing in this chapter, those are the based on the Laplace. I mean, in terms of the S only. So therefore, even though in the homework problem, you will be noticing, I think problem number 5, problem number 1, problem number 8, all you have to express in terms of the S only, Laplace. I mean, the meaning is the same that you said, that is the meaning, but all will be in terms of the S, Laplace. Okay, so therefore, now let's have a look the next problem. Everybody see, there is another problem here. Read the problem. For the following S domain circuit, again it is in S domain, find the transfer function Hs V0 over Vi. So in this case, you see this is 1 ohm, this is 1 ohm, this is S, and this is 1 ohm. And here it is V0. So you have to, in this case, find out V0 over Vi. This means Vi, this is the input, this is as it is. You just need to find out V0. I mean, exactly the similar process that we did right now in the previous problem. So if you can find out what is the current flowing through 1 ohm, and that current multiplied by 1, that is your V0. But in this case, you see the total current is not given, even in terms of the symbol or letter, it is not. So you need to find out that one. So therefore that is one question. Then question number 2, the impulse response. So this means that del T value that I was showing you in the definition, this one, HT. And then the next question, the response when VIT equal to UT. This is in time domain, you have to find out response. This is not for the transfer function. And also, what is the response when VIT is 8 cosine of 2t? This means if this VIT is UT, then what is the response? V0 t. And if this is, then what is the response? V0 t. So therefore, there are 4 questions. So therefore, first let's say start the first one. Transfer function is V0 over Vi. So therefore, as I told you that if you can find out the current flowing through this one, this branch, then that current multiplied by 1, that will be your V0. So therefore, your target is to find out this current. Therefore, let's have a look. Okay. So everybody see what I have written. First, I am calculating the total current, IT. What is IT? IT will be your this Vi over the total impedance. So therefore, first look, this is S plus 1, and then this will be in parallel with this one, and then that combination will be in series with 1. I believe everybody understand this one. So exactly I did that one. Vi over that 1 plus on parallel S plus 1. This means this one, on parallel S plus 1. So that I am doing. And then on the right side, I am making that calculation. On parallel S plus 1 means like 1 multiplied by this one. And then in the denominator, S plus 1 plus 1. So S plus 2. And that I am placing here for this calculation. So Vi over 1 plus S plus 1 over S plus 2. And then I am just simplifying it. Then S plus 2 went into the numerator, and in the denominator S plus 1 and then another S plus 2. So S plus 2 plus S plus 1. So just I simplified VIS plus 2 over 2S plus 3. Okay. And You see, once I got IT, this is my IT expression. Then as I said, because V naught is here, you have to find out this current, this one. So this means that total current IT multiplied by this one, divided by this plus this plus this. That will be your IT according to current divider rule. So everybody look, exactly I am doing that thing. So IS plus 1, IS plus 1 means just I expressed in that way for your easy understanding. S plus 1 through this branch, that current is this IT, this is total current. This means directly I have written this total current multiplied by 1, on means this one, and divide by 1 plus S plus this one. Look, this one. And then I am simplifying. So after simplification, I got VI over 2S plus 3. Everybody, could you follow until now the calculation?
Yes.
Yeah. So I mean, everything is done. I have done in detail, so you can easily see. And then once I got IS plus 1, VI over 2S plus 3, this means this current. And then because you need to find out V naught, so that current multiplied by 1. So that is your V naught. So exactly, you see, I am doing that. V naught is 1 multiplied by this current. And this means this is VI over 2S plus 3. And then as you can see, I am done. I can see V naught, I can see VI. And that is what I have been asked to find out. Transfer function Hs is V naught over Vi. So I am done. So I can write Hs V naught over this Vi on over 2s plus 3. And then I wrote in that format equal to on over 2 into s plus 3 by 2. So because I want to do further from here, I want to go beyond this point. That's why I expressed in that format. Like 2 common factor s plus 3 over 2. So this is the answer for the first one, first question. Now look the impulse response. Impulse response. So therefore see the next calculation. Everybody, one top. Let me make it bigger. Okay. Everybody see. So ht Laplace over hs, which is half e to the power minus 3 by 2 t ut. So this means that because it is asking that impulse response, so see at the beginning today I started, everybody look, this one actually, you have to find out ht. As I said, you see, ht is called the unit impulse response of the network due to a unit impulse excitation. So ht means Laplace inverse hs. And what was the hs? Hs was actually the transfer function. So therefore, the result that you got from the previous step transfer function, you just make its inverse Laplace. That will be your result ht. That is the thing here I am doing. So you see ht Laplace inverse hs. So what was my hs in the previous step? Look the very last line. Everybody see, this was my hs on over to s plus 3 by 2. Now if this is the Laplace function, then in its inverse transformation, e to the power minus 3 by 2t, just by looking this one. So that is directly what I'm writing. And then ut. Everybody, could you follow me? This inverse Laplace transformation?
Yes.
Yeah, great. Now look, everybody, the question number C. Question number C is find out the response when VIT is ut, as well as when VIT is 8 cosine of 2t. This means for this circuit, if VIT changes, VI becomes ut, then what? And if VIT becomes 8 cosine of 2t, then what? What is the response? That is the meaning. So therefore, 2 more steps we have to do. So therefore, everybody see, when I wrote that, when VIT is ut, and you all know that ut means its transfer function is 1 over s. ut means 1 over s. So then I can write V naught is hs vis. because that is my definition of transfer function. Hs is V naught over Vi. So from there I could write V naught S is Hs multiplied by V on S. And then this V on S is, this is 1 over S that I have written. And what is my Hs? That Hs I got, already I got at the last step here. My Hs is this one, 1 over 2 S plus 3 by 2. So that's why everybody see Hs is that one. And oh, sorry, I'm looking. Yes. So Hs is this one, and then Vi is this one, 1 over S. And then 1 over 2S, S plus 3 by 2. Now, because you have to express in time domain, this one, that's why you see I am applying the partial fraction or whatever residue method or cover-up method you use. I got A equal to 2 over 3, B equal to minus 2 over 3. And then I'm substituting. This means B naught S is 2 by 3, and then this 2 1 over S minus 1 over S plus 3 by 2. And then again here you apply the inverse Laplace transform. So finally I'm getting V naught S. This is 1/3. This is 1 minus e to the power minus 3 by 2 ut volt. So could you follow me, everybody?
Yes.
Yeah, okay. Just see the step-by-step calculation. And then next question, when Vi was 8 cosine of 2t, again the last one, if this Vi becomes 8 cosine of 2t, then what? So therefore, Vit is 8, and then what is the meaning of this one? What is its Laplace transformation? 8s plus s square plus this 2 square. That 2 square I have directly written 4. So this is coming from the Laplace transformation of this one, 8s over s square plus 4. And then again, I mean exactly the similar process that I did before. This means V naught S is transfer function multiplied by VIS input. So that I am writing. This is my VIS, this one, and then my HS that I got before, in the previous step. Again, the same thing, this one. So I am substituting those on, and then I am simplifying. But you see the function V naught S, 4s over S plus 3 by 2 multiplied by S squared plus 4. Therefore, now you have to either apply the cover-up method or you have to apply the partial fraction. So I am applying the partial fraction. I'm assuming this one is A over this one plus Bs plus C, because there is S squared. So it is not just B, not just C, it is Bs plus C, partial fraction rule, S squared plus 4. And then after calculation, I got A equal to minus 24 over 25. I just wrote in that way instead of expressing in decimal. And V is 24 over 25 and C was 64 over 25. And then I'm writing, so V naught is just substitute A, V, and C value, those values. So this is my format. V naught is 24 over 25. And let me make it bigger. Okay. And then minus 1 over S plus 3 by 2 plus S over S square plus 4 plus here 4 by 3 multiplied by 2 by S square plus 4. And then you make the inverse Laplace. So therefore, this is 24 over 25. Its Laplace inverse e to the power minus 3 by 2t plus for this one cosine of 2t. And for this one, this is 4 over 3. 2 over S square plus this one is sine 2t and then ut. That's all. Everybody, could you understand?
Yeah.
Yeah. So therefore, this is just calculation. You see here directly I have written ABC, you need to line 1 or 2 more line. Because I have already uploaded, so later after the class or at your home, you just make practice once you take pen and paper and then you calculate, definitely you will be getting these values. And then you substitute in that there, and then this is your V naught. And then from there, as I said, just you look those table, or if you can remember the inverse Laplace, the what will be its inverse Laplace? This one. This one is cosine of 2t. But this is, I mean, this and this looks similar. This is s over s square plus 2 square, or 4. This is 2 over s square. But this will be sine function. And then if it is s in the numerator, then it will be cosine of 2t in inverse Laplace transform. So therefore, look those table 14.1, 14.2, then easily you can find out what will be its the inverse Laplace transformation of the time domain function. So that's all. So therefore, if you have understood this problem, then now I think you're ready to solve the problem number 1 in the homework set 3. So very first problem in exactly similar to this one, this problem that I discussed right now, the very first problem. Okay, so moving forward, now there is one important discussion today, and that will help you solve your homework problem as well. You see, the topic is network synthesis. Network synthesis. So what does that mean? So everybody say, network synthesis means to find out a network that represents a given transfer function. I mean, so far we have a circuit, and then we calculated the transfer function. And now what we are doing, we have a transfer function already given. So everybody see, for example, given the following transfer function, realize the function using the circuit in figure 1. So look, this is a transfer function, which is V naught over VIS for this circuit. This is V naught, this is VI, although these are in time domain. And in the circuit, there is L, there is C, there is resistance. So those values were not given. Everybody say, the values were not given. This is VIT, this is V naught T, but its transfer function is given. So this means definitely this transfer function has been constructed or has been developed based on those parameters, missing parameters. So that's the question, what are the missing parameters? So that's why, given the transfer function for this circuit, now two questions, select R equal to 5. For example, if this R is 5 ohm, then what should be the value of L and C? And then the other question, if this R is 1 ohm, then what should be the value of L and C? So that's why, because from the transfer function, you will be finding the circuit parameters. That's why that is called the network synthesis. Synthesize. Synthesize means like compose. It is decomposed and then you make a composition. That is the meaning of network synthesis. So it is finding a network that represents a given transfer function. It's pretty interesting. And in real life, many times you will face this situation. That's why I have brought this thing in front of you. And I think the problem number 8 in the homework, problem number 8 is very similar to this one. Therefore, everybody please now understand, and then you are ready to solve all the 8 problems in the homework. So therefore, everybody say what we have to do, how to solve the missing elements, L and C, those parameters, given that R value is 5 ohm. So this is the transfer function, but you find out the transfer function for this circuit. So what you will be finding out? First of all, this is in time domain. You convert into Laplace domain. First, you convert this circuit into Laplace domain, and after converting into Laplace domain, you find out V naught over VI. V naught is, V naught is over VIS. Because you see, V naught over VIS, that expression was given. And then, as it is, what you are finding in terms of L and C and R, what is your transfer function, how it does look like, and then you will be making similarity. So definitely, if you solve that, if you find out the transfer function v naught over vi, definitely there will be something in the numerator and there will be something in the denominator, the function of s. And then one by one, point by point, we will compare with this one. What is my numerator here? That numerator will be 10. And then exactly I have to express in this format like s square plus some constant s plus some constant value. Exactly point by point we will compare, and then you can find out this thing. So therefore, everybody see, first what I said, first you find out the transfer function, and then at the very first step, you find out the Laplace equivalent for this one. So that I am doing, everybody see, the very first task. That is, I expressed in terms of S, output with S, and you see, it was the inductor. So what it will be? It will be SL. So therefore, the simply it is SL. And for capacitor, 1 over SC. And you see, there is no initial condition mentioned. So therefore, you need not to be worried about those considering the or taking into account the initial condition. So therefore, this means without or neglecting initial condition. So that's why L will be SL and C will be 1 over SC. That I did. And R is as it is. So therefore, you see, what I am doing at the beginning, I am doing the GT. What is my total impedance for this circuit? That I am first doing. So what is my total impedance? Everybody look. So these two are in parallel and then with series with this one. So this means SL plus this one. R multiplies by 1 over SC divided by R plus 1 over SC. And then you just simplify. This is SL plus this one. SC got cancelled. R over 1 plus RSC. And then once I got GT, I am finding out the total current here. What is the total current? This means everybody look. Total current IT is this VI over this GT, this one, total impedance. That is the total impedance. And then because you have to find out V naught, this means you need to know the current flowing through R, this current. So therefore, I have given the name of that current IR. And then I am applying the current divider rule. This means total current multiplied by this impedance, you see, IT multiplied by that one, divided by this plus this. That will be my this current divider rule. And then once I got IR, so what is your V naught? Your V naught is this current multiplied by R. You see, just I have written in that format, V naught is IR multiplied by R. Everybody, could you follow me so far?
Yes.
Yes.
Yeah, great. So therefore, once I got this one, and then just substitute those values. Here you substitute IR this one, and then again IT you substitute. In that way, you will go ahead. So therefore, see the next calculation. So therefore, that I am doing. Let me make it bigger. Okay. So everybody see that V naught is RIT over this one. So that I was doing here at the last step, this one. So this means I substitute this one. Okay, and then I'm going ahead. So then I substitute the value of IT, VIS over that one, that I did here. You see this one. And then I am simplifying. And then here you can see there is VIS here. So that you have to do V naught over VIS. Because in the circuit, you see, for this circuit, what was your transfer function expression? V naught over VIS, V naught over VI. So that's why everybody see, you can see here VI, then like you are done, V naught over VI, I got, and then you just simplify. And then I am just simplifying. and then this is my HS, transfer function. So now everybody say, I got HS in this format, where there is something numerator which is R, and in the denominator, R plus SL plus AC square RLC. Now everybody see, here with the AC square in the denominator, something is multiplied, which is RLC. So this term is fine. L is multiplied by with S. This is constant. I am just making similarity with this one. Everybody see this expression which was given. 10 over AC squared plus 3S plus 10. This means your 10 is a number, and then in the denominator it is AC squared. There was nothing multiplied with the AC square. And then S multiplied by some number and then constant. So exactly I like to make in this format, and then I can compare point by point. So because there was nothing multiplied with AC square, just 1. So similarly, because here RLC is multiplied, I want to make it AC squared. So that's why the transfer function, what I am doing, I am dividing both numerator and denominator by RLC, so that like it will be only AC squared. So therefore everybody see, in the numerator R over that RLC, in the denominator it became AC squared. This term became SL over RLC, and then this term R over RLC. And then just to simplify, in the numerator RR cancelled, 1 over LC. This is AC squared. Here your LL cancelled, 1 over RC multiplied by S. Here RR cancelled, 1 over LC. Now see, this form corresponds to that given form, 10 over this one. Some constant divided by AC square plus S multiplied by some constant plus a constant number. So exactly I made in that format. So everybody see what I am saying? This one. Some constant divided by AC square, S multiplied by constant plus a constant number. And then you see 1 over LC, here 1 over LC, it is the same. And exactly look that one, there also it was the same. It was 10 and then that number was 10. So now because everything is now matching, so if you compare with that given expression, everybody look, 1 over LC numerator or this thing, what is that? That means that is my 10. So I have written from here, 1 over LC is 10. You see this 10 or this 10. So once I did, and so you can say LC is 0.10. And now, and what I have written, what is 1 over RC? 1 over RC means, you see the expression, it was 3S. Therefore, you can say that 1 over RC here, that is the 3. So now R value is given in the problem. You see, it said the select R5 ohm and then find L and C. And other question, find if R is 1 ohm, then find out L and C. So therefore, everybody see, 1 over RC is 3, R is 5 ohm. So this means from here, you substitute R5, C value is your 66.67 millifarad. And then substitute this value there. So you will be getting 1.5 Henry L value, because your LC is 0.1. So once you get C value and then plug in there, so you will be getting L value. So this means my L is 1.5 Henry. Similarly, when R is 1 ohm, your capacitor value is this, again by the same reasoning, and L value is 300 millihenry. So that's all. So I constructed the circuit with the help of the given transfer function. Everybody, could you follow? Do you understand?
Yes.
So everybody, so Emma, could you follow me?
Yes.
Yeah.
Yeah. So once again, everybody try to understand. So, I mean, we are going like reverse way. So far always we calculated the transfer function. In this problem, transfer function is given, then build the circuit. That is the meaning. That given the transfer function, realize the function. So this means what is 10, what is 3? That is the meaning. So those are the values of some missing element. So this is the circuit. This transfer function has been constructed from this circuit. What are the missing components or parameters? That's the question. So therefore, two problem, when R is on or when R is dim, what is the value of L and C? So that's why, and that is called that network synthesis. I mean, constructing or building or realizing the circuit from the given transfer function is called the network synthesis. So that's why first we have to find out the transfer function from this circuit and just match with the given transfer function. That is your task. So that's why that we are doing. After converting the circuit into Laplace domain, then I constructed that transfer function. And then once I got the transfer function, I mean, this is my first line. Sorry, this is my first line, but I have to make similarity with the given transfer function. So that's why just by looking, and then by looking what was available here. So that was my start point. So you see, this is your start point that only 1 was multiplied with s square. There should not be any number, any constant. That you have to do here. So everybody see this one. Therefore, s square you have RLC. This way, how to eliminate this one? You divide numerator and denominator by that number. Exactly that I did. So that I can make a good format or similar format to the given transfer function. And once you do that, then you just say, oh, it is 1 over LC here, but here in the numerator 10, or here it was 10. So this means I have LC on, I have 1 over LC. This means that is my 10. And then here S is multiplied by with 1 over RC. So here it is 3. This means that is my 3. So therefore, that's why I wrote 1 over RC is 3. And then R is given, find out C. From here, find out L. The same thing, the repeat for if R is on, what is C, what is L. That's all. So therefore, if you have understood this, and exactly you have to do similar things for question number 8 in the homework 3. Exactly you have to do the same process. Is everybody fine?
Yes.
Okay, so great. Yeah. So then once again, when you are at home, please look, then you will be fully fine. And then in any time, you are most welcome to communicate with me. And don't hesitate to communicate with me. Okay, so therefore, moving forward, you see, I think in previous class, although I had the plan, I set up this problem, but I didn't get time to cover. We ran out of time. Everybody see this problem. For the following circuit, determine I naught t. So again, this is the time domain circuit, 2 ohm, 1 farad, 2 Henry, 1 ohm, I naught. And this is a current source, as you can see, current source, 5 e to the power multiplied by, e to the power minus 2t ut, ampere. So there is a current source, determine I naught t. So therefore, what you will do, just apply the current divider rule. You look, this current is going at this point, and something is going this way, which is I naught, and something is going this path, this branch. So your goal is to find out the I naught. So this means this is total current multiplied by this one, divide by this plus this plus this plus this. That will be your I naught. So then you are done. So what you have to do, because this is time domain, at first you find out its Laplace equivalent. First task is find out its Laplace equivalent. So therefore that I am doing, everybody see. First I am making the Laplace equivalent of that circuit. So this is 2, this is 1 over S, because this is the capacitor and there is no initial conditions involved. So it is neglecting initial condition. So capacitor will be 1 over SC, inductor will be SL in that format. So that I am doing 1 over s. Then this is 2s. This is 1. And you see this one 5 e to the power minus 2t. This means this is 1 over s plus 2. 1 over s plus 2. Therefore 5 multiplied by 1 over s plus 2. This means 5 over s plus 2. Now go ahead, find out I naught. Apply the current divider rule. So this means your I naught is, this is your total current, 5 over s plus 2 multiplied by this impedance, 2 plus 1 over s, and divide by this plus this plus this plus this, current divider rule. And then just simplify. You simplify, I am simplifying, I am simplifying, I'm simplifying, and then I got this format. I naught is 5 over s plus 2 multiplied by s plus 1. Now, because the circuit was in the time domain and you are asked to determine I naught t in terms of time function, so you have to go back into inverse Laplace. So therefore, this is my format. I am applying again the partial fraction. You apply the cover-up method, no problem. And then I got a minus 5 and v5. And then finally I got I naught minus 5 over s plus 2 plus 5 over s plus 1. Therefore from there my I naught is, you see, 5, this one, e to the power minus t. I am writing this one at first. And then minus this minus e to the power minus 2t. And 5 is the common factor. So I am done. This is my answer in time domain. Everybody, could you follow?
Yes.
Yeah.
Yeah. So just it's a matter of calculation. Once you construct the circuit correctly, once you convert the Laplace domain circuit correctly, all element, and once you are writing the equation correctly, whatever current divider rule, voltage divider rule, equivalent impedance, rest of the thing is just the calculation. And if you don't make any mistake in any step, then you will be getting the exact result. That's the thing. Okay, so and then I have one more, the last problem for today, and then you are ready to go. See this one, this is the last problem. For the following circuit, find out the input impedance G in S. Again, this is just the circuit. What? Find out G in S. This means I am asking find out the Laplace equivalent impedance. That's why it is S. I mean, in Phasor chapter, you all did a lot about this thing, but here express in terms of Laplace. That is the meaning. So this is 1 Henry, this is 2 ohm, this is 1 ohm resistance, this is 1 ohm resistance, this is 0.5 farad capacitor. So therefore your first task is convert all of these components into the Laplace domain. I mean, these three are resistance, here is it, just this will be SL, so S, and this will be like 2 over S, 1 over SC, your C value is 0.5. And then you see these two are in series, parallel with this one, series with this one, and then whole combination is parallel with this one. So therefore look the solution. Here everybody see. First I have converted those into Laplace domain. Inductor became, because it was 1, so just S, and this is 2 over S. I have written down those things like j omega L is S, L is S, 1 over j omega C, 1 over S, 2 over S. So what is my GNS? Everybody see, I have written. You look, 1 plus 2 over S, this one, which is in parallel with 2, therefore 2 parallel this one, and then that combination is in series with 1, that I have written, and then this whole combination is in parallel with this one. And then you just simplify. You just go ahead, simplify. This is your result. In the numerator is 6 plus 5s, denominator 6 plus 7s plus 3s square. That's the result. I cannot simplify much more than that's the result. Could you follow me, everybody?
Yes.
Yes. Okay, great. Yeah. Yeah, so that's all. So with that, I believe now you are able to solve any circuit problems by using the Laplace transformation, whether it has the initial condition involved or not. Therefore, accordingly, I have set off those 8 problems. If you can solve all those 8 problems in the homework, then you are done for this chapter. So I believe you can do again in the midterm exam too, or final exam, or FE exam, or anywhere in your life. You can understand and you can solve. Okay, so with that, does anybody have any questions, comment?